Question 11. A river was sampled at 5 sites as shown in the diagram below. So you've got, obviously starting here, site 1, and the river is flowing down this way. It says direction of flow. And we've got a sewage works at this point. So at this point here, we're expecting there's a big pollution event. That's really what we're talking about. And so as you go further down from here, that pollution is going to be diluted. Above it, we should have no pollution at all. So the following tables show the results of analysing the samples. So we've got at site 1, so remember this is the bit above where there's the pollution. We've got 1.2 level of oxygen. And then it drastically drops down, 0.04. And then it starts to increase again and it's almost back up to normal by 5. Okay. Number of bacteria, we have 500 at 1, so that's at a very low level. And then we've got, sorry, I'm just going to restart. Okay, question 11. A river was sampled at 5 sites as shown in the diagram below, and we've got our little diagram with our 5 sample points, 1, 2, 3, 4, 5, and our sewage works. So what we're expecting is that right here at 2, you're going to get a big pollution event from the sewage works. And then that we're going to get, this is going to dilute as it goes further down, so we've got less and less sewage as we go down, okay? Above it at 1, this should be clean water. This should have not any pollution in it. So then they've done some samples. So at site 1, so our good site as it were, the one where we've not had any pollution, the oxygen was at 1.2. And then it's dropped drastically, 0.04, so it's basically gone through the floor. And then it's gone back up again, and we're almost back up to normal by 5. Okay. In site 1, the number of bacteria is at 500 bacteria per 100 mils of water, which is not particularly high, okay? But then at site 2, it's 150,000 bacteria per 100 ml of water. This is massively jumped up. And that's because what you've done is put in a pollution, which is basically just food for bacteria and fungi. This is decomposer food. So they've shot up in numbers, and then it's gone back down again because we've got less and less of it around. Okay, so that's what those table 1 is telling you. Table 2, what we have are various different organisms, and then they've taken samples of them to see how many of them you have. Okay, so mayfly nymphs, site 1, remember that's our kind of clean water, 23, and then nothing at site 2, nothing at site 3, nothing at site 4, just starting to recover a bit at site 5. Okay, right, so all this information is what you're going to use. So use the data from table 1, describe the relationship between the number of bacteria and the oxygen level. So this is a pretty straightforward link, okay? So the lower the oxygen, okay, the higher the bacteria. You have to mention both of them, and you can put it down whichever way you like. So you can say the higher the bacteria, the lower the oxygen, or you could say the lower the bacteria, the higher the oxygen, or the higher the oxygen, the lower the bacteria. Okay, as long as you've given this relationship, okay? Both of them named. Methylene blue is a chemical which can be used to compare oxygen levels in the water. The lower the oxygen, the faster the methylene blue changes from blue to colourless. A sample of water from each site was tested. Predict which sample would lose its blue colour fastest. So it says the lower the oxygen level, the faster it changes. Okay, which one would change fastest? Lower the oxygen level. Go back over here, you're like, that's got to be site 2, because that's the one with the lowest oxygen. Use data from tables 1 and 2 to answer the following. State which of the organisms would be found in areas of high oxygen content. So our high oxygen content is basically at 1. Okay, so which would be found in areas of high? Basically it's these guys. Okay, the freshwater shrimp, you could argue, maybe, because it's a 2 and then it's only 1, but then it still had one of them at the 0.54, which is half of the top level. So I think really we're looking at these guys as being the most prevalent, in biggest numbers, in the best kind of oxygen level. So mayfly nymph, stonefly nymph, caddisfly larvae. I would really go with the nymphs. Okay, you'll get the mark for getting these 2. These ones are not going to take your marks off, but you want the nymphs basically. Sewage in the river is a form of water pollution. Describe the effect this pollution has on the number of different types of organisms. Well, okay. Site 1, 1, 2, 3, 4, 5, 6 different organisms. Site 2, when you just dumped in the water pollution, 2. So what's happened in the number of organisms? The number of different types, it falls as the pollution increases. Some species are known as indicator species. Explain what's meant by an indicator species. This is a straight definition. Okay, an indicator species is something that by its presence or absence, tells you about the environment. Okay, so it's a mixture of problem solving and life on Earth stuff. It's all life on Earth in terms of the context, but you do have to do quite a bit of back and forward for the actual paper. Okay.